Assalamualaikum viewers, please like, share and subscribe this channel. Links of PDF files used in this video are given in description. So today's lecture is about estimation of nickel by gravimetric analysis, and we are using dimethyl glyoxime or DMG as an organic reagent. So this slide gives the experimental setup of this gravimetric procedure. So first of all, we will take the So today we will perform gravimetric estimation of nickel by using dimethyl glyoxime or DMG as an organic reagent. So the question of this experimental procedure is to determine the amount per liter of nickel plus 2 in a given sample solution gravimetrically. You are provided with 1% solution of dimethyl glyoxime or DMG as an organic reagent. So the analyte of today's experimental setup is about nickel plus 2, and we are finding this nickel plus 2 by using dimethyl glyoxime or DMG, which is acting as an organic reagent. So the technique we are using is called as gravimetry. So the word gravimetry means gravi, which means weight, whereas metry, which means to measure. So gravimetry means measurement of precipitates. So how these precipitates are formed? We will make a complex between DMG or dimethyl glyoxime and nickel, and this complex is formed, and in this complex the precipitates are actually formed, and when we measure the weight of these precipitates, then that method or technique is called as gravimetry. So actually a complex is formed between analyte, which is in this case is nickel, and organic reagent, which is DMG or dimethyl glyoxime. The complex formed in this form is actually insoluble precipitates, and we have also done titrations of complexometry type, in which also a complex is formed and there is color change, but those were solutions. But this particular case is involving a complex which is formed in the form of insoluble precipitates. Now what we will do, these precipitates are separated then by filtration, and they are dried, and then we measure their weight, and the weight of these precipitates is directly proportional to amount of analyte. Like if we are getting a large yield of precipitates, then it means the analyte present in that sample solution is greater in amount. So in order to promote a good precipitation, a high molecular weight organic reagent is used, which can selectively make a complex with a metal. So there are large number of organic reagents, but we will choose that organic reagent which has high molecular weight. High molecular weight means when it will make complex with metal atom or ion, then due to its large weight, the precipitates formed will be very thick in nature, and it will be easy to filtrate them, and that is why we are using a high molecular weight organic reagent. Next, this organic reagent should be selective or specific. Like selectivity means at 1 pH, at constant pH, it select only a particular metal, and it may complex with that particular metal. So in order to do this analysis, we have used dimethyl glyoxime as an organic reagent, and it makes a very thick rose red color PPTs with nickel plus 2. So that is why this is the advantage of using dimethyl glyoxime. Now the reaction between nickel and DMG is specific, and it is so much specific that nickel, if it is present in parts per billion range, then DMG is able to make complex with this little amount of nickel. So that is why we are using DMG for the estimation of nickel, so that it can even react with very minute of nickel analyte in the given sample solution. So this slide gives the experimental setup of this gravimetric procedure. So first of all, we will take the analyte solution, and this solution is definitely in dissolved form. So we have taken approximately 20 ml of nickel chloride solution, in which we have to measure the amount of nickel. So this is actually the analyte solution. Now what we will do, we will take this solution, and as the complexation between nickel and DMG takes place at basic pH, so we will add 2 to 3 drops of buffer so that the pH is crossing 10. So we will make this solution basic in nature. After that, we will add drop wise addition of dimethyl glyoxime or DMG as an organic reagent. Now this DMG, because it is organic compound, so it is dissolved in alcohol, so we have prepared its 1% solution in alcohol. So this is the reason why we are adding drop wise addition of DMG. Here a question may arise that if we can amount DMG in excess, and only the nickel which will make complex with DMG will form precipitates, and excess amount can be filtrated. But why we are adding drop wise addition of DMG? The reason is that because this solution is prepared in alcohol, so 1% solution of alcohol is also adding along with DMG. So what will happen that after making complex with nickel and DMG, this complex is because neutral and its nature is almost organic, so it can back dissolve in ethanol or alcohol solution. So that is why we are adding drop wise or limited quantity of DMG in this analyte solution. So after that, a precipitation has been developed, and next step is the filtration of precipitates. So this is the analyte solution. Here we are using filter paper or crucible, and in order to enhance the filtration procedure, we can attach vacuum pump here. So this is the filtrate, whereas these are the precipitates. We will dry these precipitates, and after measuring the weight of these dry precipitates, we can get the yield or amount of precipitates formed. Here many things are under consideration, that this filtrate may contains unreacted amount of nickel, so we can add further DMG in this filtrate in order to make sure that there is nothing unreacted nickel left behind, and the precipitates these are formed are again crossed through this filtration setup so that we get all the precipitates. So this is the structure of dimethyl glyoxime, as it contains two methyl groups, that is why the word dimethyl, and these are the oxime groups which are present, so that is why we are calling it as dimethyl glyoxime or DMG. So as it is purely organic in nature, so we will prepare 1% solution in ethanol by taking 1 gram of DMG and dissolving in 100 ml of ethanol. So in this way we prepare its 1% solution. Now under basic conditions, what will happen that it will remove its protons from here and here, and in this way a coordinated complex is formed between DMG and nickel. And as we are seeing here that there is no charge on this complex, and this whole complex is purely organic in nature. So that is why we are adding limited amount of DMG, as now this complex is purely organic in nature, so it can back dissolve in the DMG solution, and then we can have a less amount of or less yield of precipitate. So in order to avoid that, we are adding drop wise addition of DMG. So there is no charge on this complex, that is why it is making neutral precipitates, and these precipitates are red in color. So we are seeing here these are the rose red color precipitates, and we are doing this precipitation in round bottom flask so that there is no corner in the round bottom flask, and it is easy to remove the precipitates from this round bottom flask. So this slide explains the filtration procedure overall. So here is the analyte solution in which the precipitation has been developed. Now we will filter these precipitates. So here we have adjusted the filter paper, and here the filtration flask has been attached with the wall of the beaker, so in order to have a smooth flow of the solution. So here is the filtrate, and we will not discard this filtrate. What we will do, we will now further add DMG, so that if any unreacted nickel is present, then that can also make precipitates, and then we will add these precipitates here, and we will have recovery from this filtrate solution. So here we are using a filter paper, and we are obtaining this complex between nickel and DMG in this filter paper. So before using the filter paper, what we will do, we will dry this filter paper in the oven so as to remove the moisture from its surface, and then we'll weight this filter paper, because after adding precipitates we cannot weight this filter paper. So after adding precipitates we can get the whole weight, which include the weight of filter paper and precipitates. So that is why we are using a dried and pre-weighed filter paper for this procedure. In order to enhance the efficiency of filtration assembly, we can use a filtration flask, and we can attach a vacuum pump here, so that the filtration procedure can be done speedily. So in this place we can also fit a gauge crucible or filter crucible instead of filter paper, so that the whole procedure of filtration can be performed in a quick way. After collecting the precipitates, we will dry them, and after then we will weight them. The drying procedure is very necessary here, because we cannot over dry it so that the complex can be decomposed, or we cannot do an incomplete drying procedure. In case of incomplete drying, we will weight the precipitates greater than as compared to its original weight, because the weight of the filtrate will also be present. So we will do the drying procedure for about 10 minutes at a temperature of 60 to 70 centigrade. So at this temperature range, the complex will not be decomposed, and the whole filtrate solution, which is mainly containing the ethanol solution, it will be removed and evaporated. So we will get the dried form of precipitates. For further calculations, we will only use the dried weight of precipitates. So next we will do the observations and calculations. First of all, we will measure the weight of the dried filter paper before the start of analysis, and in this case it was about 0.5 gram. It was the weight of dried filter paper. After then we have collected the precipitates on this filter paper, and then the whole filtrate was evaporated from this filter paper, and now we will measure the weight of precipitates and dried filter paper, and which in this case obtained is 1.25 gram. So what will be the weight of precipitates, or what will be the yield of precipitates? So we will minus the weight of empty filter paper from the loaded filter paper, and the answer is 0.75 gram. So the weight of dried precipitates is finally comes, and that is 0.75 gram. So if we see here the structure of this DMG complex overall, so the molecular weight of this overall complex is 289, whereas the atomic weight of nickel is about 59 gram. So we will develop a formula here that 289 gram of complex contains nickel 59 gram. So 1 gram of complex will contain nickel 59 divided by 289. And how much we have obtained the complex? So we have obtained the complex which is 0.75 gram. So 0.7 gram of complex contain nickel. So 59 divided by 289 multiplied by 0.75. So that will contain 0.153 gram of nickel. Remember that in the question we have to find amount per liter. So what we have taken the solution, we have originally taken only 20 ml of sample solution. So this weight of precipitates, which has come 0.75 gram and it contains nickel 0.153 gram. So this nickel is present only in 20 ml of solution. So we will write here 20 ml of sample solution contains nickel 0.153 gram. So 1 ml will contain 0.153 divided by 20, and 1000 ml or 1 liter will contain 0.153 divided by 20 multiplied by 1000. So it is 7.65 gram. So this is the result of this gravimetric procedure, and it is that the given sample solution contains 7.65 gram of nickel plus 2. So this was the all experimental procedure and setup for gravimetry, which has been explained in this lecture. I hope you have well understood this lecture, but if still you are feeling some confusion or have some queries, do let me know in the comment section. I will respond to your queries as soon as possible. Okay, thank you. Allah Hafiz.